Now, good afternoon and a very warm welcome to one and all present. Hope you are having a great day and congratulations on your JEE advanced results. The 2-year JEE preparation journey takes perseverance, and with this virtual education conclave by Techfest IIT Bombay, we wish to bring you the information tool to satisfactorily conclude the journey by choosing a technical stream and college. So keep your questions handy. We'll be starting now. So, hello everyone, my name is Prajwal Rao and I welcome you all to the first edition of Virtual Ed-Conclave by Techfest IIT Bombay. Techfest IIT Bombay is Asia's largest science and technology festival, and before you all become engineering students getting to attend it in person, let's have a look at its after movie. That was a marvelous after movie for Techfest 2019-20. Let's dive into the session now. Let me introduce the esteemed speaker for the same, Professor Amit Agrawal, Professor of Mechanical Engineering as well as Dean of International Affairs. Welcome, sir, and thank you for being part of our Ed Conclave. Handling over to you.
Okay, good morning, good afternoon, Virtual, and good afternoon, everyone. It's really a pleasure to have you all in this session. So first of all, let me congratulate you for cracking the JEE exam, one of the toughest exams anywhere in the world. And coming this far, I'm sure you have a lot of plans for how you would like to see your career shape up. Of course, this session will try to give you some information on that. And let me also congratulate all the parents who I'm sure have made a lot of sacrifices, a lot of efforts along with their sons and daughters to see you through, pass this examination. So let me first share my screen, and then we'll start sort of discussing some of the simple things that I have for you. So can you confirm that you can see my slides? Rajwal, can you see my slides?
Yes, sir, we can see your slide.
Okay. So basically what I'm going to talk about is mechanical engineering at IIT Bombay. This is what I have labeled it here. But I will be talking about engineering in general a little bit, about mechanical engineering after that, and then about mechanical engineering at IIT Bombay. So this is the plan that I have for today, for this afternoon. And I'm sure you have a lot of questions. So we'll try to see if we can answer some of the questions that you may have. So you may have questions like, what is mechanical engineering? Is it just related to machines, or is it more than that? Maybe what sort of jobs do mechanical engineers get? How much what is taught is useful later? What do we expect from the ME department at IIT Bombay? So these are some of the questions that we may have at this stage. Of course, it is not possible to do justice to all the questions. But I will try to give you a partial answers. So the answer that you may be seeking for may also depend on, or there may be a lot more questions depending on who we are looking at, what is your future things that you have in mind, etc., etc. So it may vary quite a bit, but we'll try to cover some of these points at least partially, and then we can take more of these in the Q&A session after this, after my presentation. So let me start off by making some general comments. I will start off by sort of comparing science and engineering. Now, what are these? Because you are starting from science, this is your background. You have been looking at from maybe class 7th or 8th, physics, chemistry, biology. Of course, biology you may not have taken at this in the last few years, but that's what you have been talking about. You have been looking at science, which is essentially looking at fundamental principles behind various phenomena. If you have to sort of say it in one line, this is probably what science is. Whereas if you have to again summarize very, very quickly what engineering is all about, then engineering is application of the fundamental principles towards solving real problems. So we can say that fundamental principles is like, and looking at the fundamental principles is what science is, whereas the application of this fundamental knowledge to real problems is what engineering is about. And of course, as we said that you may have very little idea about, you have enough idea about science, but you may have very little idea about engineering. So maybe in the next 2 slides or so, I will give you a general sort of comparison of science and engineering, and what are the engineering processes that one goes through to try to solve a real problem, and what is covered in the engineering education. So that will give you some sense of the broader discipline, broader field of engineering, and then we will delve into mechanical engineering after that. So let me start off with this sort of a slide which summarizes a scientific method. So this is somewhat similar to what science does. It starts off by making observations. Then you start thinking of some interesting questions from there. You may formulate a hypothesis. Then you develop some testable predictions or gather data to test your predictions. Based on that, you either refine, modify, or reject, or expand your hypothesis. And then you move on to the general theories, and then that may lead to further observations and so on. So this is a scientific process. And if you have to take an example, we can take an example of the scientific process. So I don't want to really make it as a lecture, but I will just give you a general sense of what goes on here. So let us say that I will take a very generic example of COVID, which everybody is very familiar with. And the example that I'm taking may not be like the most scientifically accurate, but it will give you a sense of what we mean by these. And then when we go to the next slide, hopefully you can connect it better to engineering, what we do in engineering and what we don't do, etc. So, I mean, in scientific method, we sort of say that, okay, let us say that there is an observation, which is, let us say in Delhi, the spread of the disease is faster than in other places. So this is an observation that we have. Now we can say that we'll try to make some interesting questions from here. It may be related to, we can say that whether spread of COVID is related to the low temperature, which is there in winters especially, or is it because of the air pollution, which the city is infamous for, or is it because of the population density that is there, much larger than others. So is it related to any of these? And then we see that, okay, if it is related to that, maybe we can have some sort of a hypothesis that it is related to some respiratory droplets, evaporation time of that. So we then see whether drying time, if it is related to the respiratory droplets, then it may be related to the drying time. And then we try to measure the drying time as a function of various things. And that helps us to develop a more general theory and so on. So you can see that this is how a scientific process, how do you go about looking at a scientific question, and you try to come up with a solution of this problem. And once you have a solution, when you have a general theory to explain how does the spread of the COVID is related to whatever parameters. I mean, you can have a general theory, and then from there, you may try to, that theory may itself lead to further new questions, and the whole process can be repeated. And that's how you keep on moving further and further when you look at it purely from the scientific point of view. Now, if I have to look at the engineering process, if you were to compare with that, it starts off, again, you will see a lot of similarities between what we said in the previous slide and what we are going to say here. It starts off with the problem definition. This is one of the most common thing. What is the problem that we're trying to solve, which can come because it's more real life, it's more field oriented, it may come from the field, it may come from a customer. And the next step would be to, once we have a problem, we try to conceptualize a solution. So we may have some conceptual design, some solution around this problem, some ideas. Maybe we'll have to draw some sketches as to how the solution would look like. So this is still very conceptual at this stage. Then we have to start refining that idea. We have to say, okay, if this is how large or how small it should be. So then I will have to now start doing a calculation. Earlier we said, okay, something like this should work. But now how large should that be? So then that's the level, that's the step that we are taking, where we are now refining our ideas, okay, and trying to have a more concrete solution to what we have, for which we require a lot of detailed calculations. We may also resort to use of certain models and or computer simulations to aid in finding a solution. Now, once we have a solution, we may have to test that, okay, which may again require detailed analysis of whether what the solution is expected to give. Maybe again, some sort of a simulation can be done that this is the design, this is how it's expected to work. And then maybe based on that, we do a prototyping, which helps us to visualize and further improve the solution if required. So at every stage, there is a need, or we tend to improvise upon our solution, our thinking, and keep on using our understanding of the basic principles to be able to go to the next step. And then, of course, we have to communicate. Communication is very important. So if you look at the entire process, we started off with the customer's problem. We now have some sort of something that we can communicate it back with the customer and the potential customers in terms of drawings, in terms of specifications, that the solution can, that the solution that we can provide for that problem that we started off with. And then when everything looks in order, we can go for a final design and manufacturing and distribution of the solution that we have come up with. So this is the entire process. And of course, hopefully you can sort of understand that this is where we come from. So starting off from the field to the actual delivering of the solution. So this entire thing is what engineering is all about. Now, what does engineering education do? It essentially looks at the two things in blue in lot more details. Okay, so you essentially finding the solution. So we'll not really say that, okay, in some courses, in some places, we do try to find a solution, a problem, but a lot of times the problem is given to us and we are trying to find a solution for that. And typically it is beyond the conceptual design. We sort of try to say that, okay, well, this sort of thing, if we have to work, if this part of the machine has to be designed, then it has to be like this. So we are mostly in these two phases. And once we have a design, we try to sort of see whether it will be able to withstand the forces or the loads that it is designed for and such things or not. So we are mostly focusing on these parts. But once you go from this understanding, you can go to the industry. You will be going to the further steps, which is prototyping and of course the production steps as well. So this is the bigger picture, and you can sort of see the role which engineering education typically tends to impart. And so now I will move ahead, and after having given you a sense of what engineering is all about, I will try to give you a sense of what mechanical engineering is about, and also its relationship with a lot of other disciplines, what courses to be studied, what do we expect to get, and so on. So let me start off by sort of saying 7 reasons to study mechanical engineering. And as you can see, this is coming from a reference. So this is not my 7 reasons, but 7 reasons that one can look up at this from this website. And it sort of says that mechanical engineers have good graduation prospects, or prospects after prospects have good, upon graduation have good prospects, is what this first point is. They have great starting salaries. They are multi-skilled. They tend to find a way to bridge the gap which is there in the engineering skills. There are a lot of global opportunities which are there. And there are a huge variety of mechanical engineering courses that a graduate goes through. And they are at the forefront of future technologies. So as per this website, you can see that these are the 7 reasons that are listed to study mechanical engineering. And you can see that most of them are quite compelling. So to me, some of these are very compelling things are, I mean, for everybody, for different people, it may mean different things. You may want to go with the first 2. After graduation, what are the prospects? What are the starting salaries and so on? Of course, a lot of data is available in the public domain. You can look up those details. And I'm sure a lot of you also know a lot of things from the seniors and others. So, and of course, you would know that the points that I mentioned here are reasonably correct, reasonably okay. Of course, so you can go for these points. You can also go for some other points like being multi-skilled, doing a wide variety of courses, or trying to sort of enhance your the skills that you have at the stage. Or you may be interested in being a market leader or an entrepreneur. So for which you have to be at the forefront of, you should be sort of be aware of what are the technologies which could be hitting the market in a few years down the line, and how can you position yourself to take advantage of that. So, so all these things, I mean, at least mechanical engineering in general tends to do a good job and try to cover these various aspects that has been provided here in this slide. So I will move on and say that with this as the motivation to look at mechanical engineering, let us look at what goes on in mechanical engineering. So I will say that there are three broad areas in mechanical engineering. The first one is design. And the beginning we had said that is mechanical engineering all about design, all about machines. So this is what we'll try to answer here. We'll say that, okay, it is about design, which deals with designs of machines, vibrations, controls, and such things. Maybe vibrations and controls may not make too much sense for you at this stage. But still these are generic terms, reasonably generic terms that you can relate them with. So, typically these plants would have some sort of a control in their own and office machines, everybody understands. And it involves broadly, very broadly speaking, it involves working with solids. But we also deal with the other type of other states of matter, which is the second major sub area of mechanical engineering, which is broadly fluid and thermal sciences, which essentially involves working with fluids, which are both liquids and gases. And some examples of where it becomes very relevant is if you look at refrigerator, if you look at engine, they involve a lot of, so refrigerator essentially involves cooling. So it's essentially broader in the preview of thermal sciences. So here there is a refrigerant which is moving inside uh, your refrigerator, and that's what is picking up heat from the food that has been kept not directly, maybe through the contact with air, but of course it is maintaining the refrigerator at a low temperature that is cooling the air, and then that air drives off the heat from your food, and then that refrigerant rejects that heat which has been gathered from the food to the atmosphere outside. So you can see that the movement of the refrigerant in the refrigerator is very, very important. Similarly, if you look at engine, you breathe in air, you put in petrol or diesel, you burn the fuel, and then there is a combustion which happens. That's what produces power, and that's what drives your engine. And then the exhaust which has been burnt has to go out. So you can see that this is, of course, there is solid, which is your engine, but you can see that there is a lot of movement uh, of the fluids which are involved, and that's why this is the second major sub area of mechanical engineering, which is broadly termed as the fluid and thermal sciences. The third major thing is manufacturing. Of course, you can design. Both of these two are designing in different ways. Maybe think very broadly, you can think of designing with solids, you're designing with working with fluids. And then, but you have to ultimately make them. This is also within the purview of mechanical engineering. So so manufacturing deals with making of components and the elements which are involved in through the design process that we have seen earlier. So actually making them, so you have to essentially look at what will be the most suitable manufacturing process to make that item. If you have to make it, instead of a few pieces, you have to make it a few thousands of pieces. What sort of a manufacturing process would you choose, so that the cost is okay, you are not using extra material and so on. So you can see that those sort of questions sort of get answered in this manufacturing part of the mechanical engineering domain. So here you can say that material aspects is what becomes very important. I mean, if you have to very, very broadly sort of think about, it's not just material aspects, there are a lot of other aspects. But if I have to very, very broadly say, maybe I can say that material aspects becomes very important in this sort of sub-discipline of mechanical engineering. So, then I will say that although you have now broken down in mechanical engineering into these sub areas, but all areas are actually important. So if you go back to an example of car engine, it requires a lot of things. It requires flow of air into the car engine, for which you need to understand the fluid sciences, the fluid motion, the fluid mechanics essentially of the air flow of air. The air is being burned along with the fuel, along with the oxygen coming from the air. So you have thermal sciences coming to the picture. You have there are a lot of valves which control the movement of the air and the timing, etc. So you can see that valve opening and closing and their design becomes very important. So this is a whole problem of mechanisms and design. Comes from the sort of discipline of design. And then you can see that I have to look at the proper material of making my engine components. So then you can see that again, the design and the material science aspects come into the picture. You can see that I will have to uh, cast or make these, manufacture these engine blocks, the heads, the various pieces. So then the manufacturing becomes very important. So you can see that a good engineer of course, we in 4 years, we tend to look at only one aspect or a few aspects. But at the end of the day, as a good engineer, you need to know so many other aspects as well. And this example itself sort of gives you that whatever various courses and things you look at, we study, maybe they are not giving you, I mean, they tend to focus on a particular aspect, but all these aspects are important because when you go to our actual system, you need these various things. You need to know all these various elements so that you can put them together in the best possible way and come up with a solution. As we said at the very beginning, the whole idea of engineering is to be able to find a solution for a customer and so on. So moving ahead, so if we have to say what is mechanical engineering, if we have to put it in some keywords, we are going to just put some keywords because these are all sort of keywords which are relevant for mechanical engineering. It could be machines, it could be automation control, it could be robotics, it could be energy, it could be weather modeling, it could be processing of materials. So these are all something which are sort of keywords, something which is relevant for mechanical engineering. So you can see that mechanical engineering is a very broad discipline. It does not, so you can see that energy, for example, or machines or automation control, robotics, these are all, and of course, weather modeling, you know that the Nobel Prize recently announced last week was related to weather modeling. So, I mean, so Nobel Prize was given in physics. So you can see that these are all very, very broad areas, and mechanical engineering does touch upon, or not just touch, it deals with each of them in a reasonable way. And of course, then you have at the end, you have the option of getting into any of these, whichever you like, whichever you are more interested in. You can get into that, and there is a lot of opportunities for a lot of work in any of these areas. So moving ahead, I will this is probably my last general slide where we'll look at mechanical engineering and its relation with other disciplines. So see that it is essentially also related. As I said, we cannot just look at one engineering in isolation. We have to also look at how does it connect with other engineering branches. So you can see that mechanical engineering actually sits very well in the middle. It has connection with a lot of other disciplines or almost all other disciplines. So depending on what you are doing, based on that, you will have an arm which would be common or which will be intersecting with some other engineering discipline. So you could have computer engineering, for example, interaction with that if you're looking at, if you're working in robotics. So you'll have people working in robotics from mechanical engineering side, also from computer engineering side, and you'll be interfacing with them. Similarly, you would have people in automation, image processing. Okay, so here you will be interfacing. This is all relevant for robotics, sensors, and you can see that this is where a lot of interaction with the electrical engineers come to the picture. So we can have interaction with civil engineers if you're looking at environmental issues. So we talked about weather modeling and such things. So this is where interaction with civil engineers essentially becomes very important. They look at environmental from a different point of view. We look at it from a different point of view, but and that interaction is what enriches everybody. Similarly, you can look at material science, materials engineers, which again, when you are trying to develop new materials, For, again, the applications, maybe a mechanical engineering application, again, you have to interact with material engineers. Similarly, when you're looking at flying objects, which are something which is happening very much these days, people are talking about flying cars and such things, and drones and all, UAVs. So these are all something that is there in aerospace engineering domain, but you also have to connect. A lot of mechanical engineering aspects are there, and you again interface with the aerospace engineers if you're talking about designing these. Similarly, you can talk about marine engineers if you're talking about robotic fishes and submarines and such things. So this is in general what I wanted to talk about in terms of engineering and mechanical engineering. And maybe just to sort of give you a sense of what sort of courses will get covered here, what sort of things you would know. So as mechanical engineers, you will be talking about forces, motion structures, energy, materials, machines. Okay, and this is all the core part of it. And I've just given you some sense of the courses which are there. So these will be dealt with, the forces, motion structures will be dealing with in courses on statics, dynamics, kinematics, mechanics of solids, and so on. And then the energy aspect will be dealing with courses like thermodynamics, heat transfer, applied thermodynamics. With respect to materials, manufacturing courses, basics of materials, you'll be doing courses like these. Now, with the machines, we will be talking about, if I have to look at graphics, there will be graphics, design courses, machine elements courses, controls, mechatronics. I don't know how many of this will make sense to you at this stage, but these are some of the things, and hopefully from the bigger picture, once you have the bigger picture, you'll be able to see why we need these courses and how do they get connected to so many other things. We would also be doing some courses on economics, humanities, and social sciences. And with the new NEP, which is coming in, new education policy of the government 2020, which was announced last year, there is a lot more emphasis on some of these economics and other aspects. So that again, it helps you make a complete engineer and not just somebody who knows about the scientific and the technological aspects, but understands the economics and the human, I mean, basically the human side of everything and the social science of everything. And of course, we'll be talking about overall foundation, which will be coming through math, physics, chemistry, and other courses like measurements and computational skills. So these are all going to form the basics of what you do. So this is how, I mean, very, very roughly, the whole course about mechanical engineering is structured in IIT Bombay as well as any other place that you would use. This is sort of the things that gets covered in 4 years of your bachelor's. And of course, fourth year, typically you have far more number of electives. So you can decide what course, what sort of subtopic you are more interested in. You can take more courses to that. You can take advanced level courses of these and sort of tend to specialize a little bit on the topic that is of more interest to you. So as I said, I will talk about engineering and then mechanical engineering. And now I will talk about mechanical engineering at IIT Bombay. So I will start off with something about the institute, IIT Bombay. So this is a picture of the institute. And I hope the COVID will allow all of you to come back, to come to the campus very soon. So whenever that happens, you'll see this campus. It's a beautiful campus located in the heart of the city. The institute was founded by the first PM, you can see here, around 60 years back. And it is one of the few institutes which have earned the institution of eminence status from the Ministry of Education. And this status was given around 3 years back. And this is because we have now really graduated to a research institute. So we are no longer just an undergraduate providing education. There is a lot of emphasis on research and such things. So, and basically postgraduate education as well. So what you would see is that if you look at the numbers, the institute has around 12,000 students. And if you look at the percentage of undergraduate students, around 45%, 40 to 45%. And you'll be surprised that there are 25% postgraduate students, or PhD students. So that means that, and the remaining around 35% or so 30% or so are your master's PG students. So we essentially see that we have 3,000 plus PhD students on campus. We have around 500 plus postdocs on campus. So these are very advanced stage training that the institute is providing. And of course, that is because of which there is a lot of research and publications, patenting, etc., which is happening in the institute. So moving on, so these are some of the departments. I will not spend too much time here, but I will move on to mechanical engineering now. So mechanical engineering, this is at IIT Bombay. So in terms of overall numbers, this is what we have, around 60 faculty, around 900 BTech and dual degree students, around 200 MTech students, around 300 PhD scholars, around 40 postdoctoral fellows, 30 plus research labs, and 400 publications happening every year from this department. And the department has all these programs, as you know, BTech, BTech plus MTech, dual degree program, the MTech program, as well as the PhD program, and all the three major areas of this of mechanical engineering that we have already talked about, as well as there is a lot of emphasis on interdisciplinary research that I will not really talk about because this is more at the research level. And if I have to give you some sense of what sort of work, because I saw in the chat what sort of research goes on, so this is to give you a sense of the research which goes on in each of the three areas of mechanical engineering that I've talked about earlier. So you can see people talking about propellants. This is something which is funded by the DRDO, for example, the defense labs. They're interested in these propellant for rockets and such things. You can also see work being done on tsunami modeling, for example. How does it affect, and details about can it be predicted early, for example. You can also see development of micro devices. These are next generation devices that are being made by the scientists. You can also see a lot of detailed visualizations that one can see as a phenomena is happening. You can see that the faculty is looking at problems like how do the fishes swim, and the complex interaction which happens between the body as it is swimming and the surrounding fluid. So you can see that the complex pattern that you would never have imagined. This is the type of complex pattern that actually forms in the flow when the body moves and the fish flows, or rather swims. And then if you were to look at manufacturing sciences, again, you will see that people are looking at the microstructure, how once you subject a material to a certain process, what sort of structural changes happens, how do you look at that, how do you model that. And people also looking at medical devices, just like what you see here. I see some raised hand, but I think we'll come to the questions at the end. And so you can see that that sort of work goes on. Similarly, you can look at, people are looking at making these bulletproof jackets and testing them, having testing facilities, which are very high strain rate facilities. So the bullet as it comes and hit, whether it really pierces the jacket or not, etc. You can see people also looking at how do we hear, how does the sound waves travel in our ear, what sort of part does it simulate, and so on. Similarly, looking at making very complex structures like what you see here. And one can look at this structure and maybe use, and the way that our arteries and our lungs are, you can see that we can actually make structures like these in a very efficient manner and in a reproducible manner, and you can study these, the flow of air, etc., in these sort of patterns. So this is just to give you some sense, and this is just a listing of the research labs that are there. Very large number of very advanced labs which are there in the institute. And then, of course, the faculty are also keenly involved in research, not just in research, but also in teaching. And they also write a large number of textbooks based on their specialization. So you can see a large of this number of these textbooks which have come out from the department faculty over the years. And then if I have to just very quickly summarize the faculty profile of the ME department faculty at IIT Bombay, we'll just take some parameters on how they have done. So you can look at some of the best prizes or the highest prize scientific awards in the country, the Shati Sarvapatnanda Prize, the Sarojini Fellowship. See that there are faculty in the department who have actually won these prizes. You can look at it from the point of view of recognition from the fellowships as fellowships from the engineering and science academies. You see a very large number of our faculty being elected as fellows of the International Academy of Engineering, which is actually a very, very prestigious and a very competitive thing. Similarly, in the science academies, people have been elected, and then we can have editor of international journals, for example. So there are several very large number of faculty who are in the editorial board of these various scientific journals. So this sort of brings me to the last slide. So I have sort of covered what I wanted to cover. So I will now end with a small advice for, this is from my personal sort of experience, that all of you will be spending 4 or 5 years in IT. And I would like you to spend this time well. And a simple calculation will tell you that this is like at least 4% of your life. And it's not a small fraction of our time. And this is probably the best years of our life that you'll be spending in IIT Bombay. So it's good that you spend it well, whatever you do, and therefore have a goal, what you want to achieve, what you want to do. And the higher the goal is, the better it is. And I would say that if you have to identify a goal, identify a need that you would like to address, and then see if you are interested. So there may be a large number of needs that you may identify, but find a need that you are interested in identifying and addressing, and then actually go ahead and work very passionately towards addressing that need. So this is essentially just like what you have done through your JEE thing. You, at your class 10, 9, whatever stage, you decided that you will go for this IIT, you spent all your time, effort, etc. You can see that that is one part of the thing, but here now is you enter a professional career, the expectations, the goals can be much higher now because the training that you would have will be much larger. And therefore you can have a higher goal for yourself and try to work passionately. Just like you, to achieve or to be able to crack this day, you have to spend so many hours and effort, make so many sacrifices, personal sacrifices. The same thing goes on further in your career. So this is my advice to, if you, the earlier and the better goal you identify for yourself, the better you'll be able to address that. And of course, you'll have to work passionately towards it. So this is all I have. And I think we'll go to the question answers now.
Thank you, sir. The talk was exhaustive and covered most of the questions asked in the chat. Handing over to Isha.
Hello, Professor Amit. I would just like to express my gratitude on behalf of the entire Techfest team. Thank you for coming on our invitation, and thank you for guiding the students. If there are any remaining questions, I hope it's all right if we can email you. And in the interest of time, I'd like to conclude the session. Thank you so much for coming.
So you want me to, I mean, how do you want to take up the questions now? Want me to read something from the chat, or you are?
So the questions were covered in the session. It was like you were reading through them.
Okay.
If there are any residual questions, then we'll make sure that they reach you through.
Okay. So expect the people to just turn on their mic and ask the questions, or you want them to type it out?
So the questions, like whatever content was there in the slides, it was covered entirely. If anyone feels that the question is remaining, then we'll send the questions over to you later after the session. We will conclude the session for now.
Okay, fine. Sounds good. Yeah.